Hello everyone and welcome in a new video. And now in this video we are moving forward in a process management series. So in this video what we are going to do, we are going to understand about the process states. Okay, so in my previous video we understand about PCB, process control block or process descriptor. So now in this video what we are going to do is, in that thing, in PCB there are some attribute called state. In PCB there is a attribute called state, which basically define the state of process. Means process is in which state. So what kind of states does the process go through with? Okay, so we see these things and understand that every level of process. Okay, so the process state will be look like new. We will understand this thing, that what is basically a new is. Okay, so new, and then ready, and then running, termination or terminated, and wait, or you can say block. So the process state basically go through with these 5 states. So in PCB block the state will be like new state, running state, wait and block state, a ready state or terminate state. Okay, so now understand this thing, that what basically happen in a new state, what happen in a ready state, what happen in a running state, and what is the purpose of a wait block, and how the process basically terminated. We see these things. Okay, so first of all we talk about from our starting one, which is a new state. Okay, so new state is what? New state is basically the initial state of a process. New state is what? New state is a initial state of process. What does that mean? For example, let's take an example like you have a mobile phone. Okay, so you have a mobile phone, you have a lot of apps in your phone. Apps like you have some games like doctor driving, and you have a calculator app, and you have a WhatsApp app. So you have so many application in your phone. So what okay, so you have so many application in your phone. So what gonna happen if you click some of the application? For example, if you click on the WhatsApp, so when you click on the WhatsApp, now this is what a new state is. This is what a new state is, means all the installed processes are known to be in a new state. Means everything you see on your phone, means like for example WhatsApp, calculator, doctor driving, and anything you see on your phone or on your desktop or anywhere, basically from a system or from mobile phone, anywhere. If you see these things, if you see these graphical user interface, so all these things are basically a new state. All these things are what? All these things is basically a new state. So what is a new state? All the installed processes is known to be a new state. All the installed processes is known to be a new state. Okay, so everything you see, GUI basically is a new state. Remember thing, if everything is basically in a new state, and a new state doesn't mean that your process is in the main memory. So what the basic structure is, we have CPU, and we have a main memory. In main memory we have operating system, and we have a programs. So what happen is, basically PCB of a program goes to the CPU, and CPU execute your program basically. Okay, so PCB of P1 and PCB of P2. So what happen is operating system transfer the PCB of that program and CPU execute that thing. So when your program is basically executed, when your program is in a main memory, then only operating system can create a PCB and send that PCB to the CPU to execute. Okay, so what is the important thing? That your program should be in a main memory, your process should be in a main memory. So what happened in this case, in a new state, your program is basically not in a main memory. Your program is basically visible to you that okay, in my device these are the applications, so that's it. Okay, so your program, your application is not in a main memory. This is what an important thing. Okay, when your process is not in a main memory, it is in a new state. Okay, so all the installed applications, all the installed processes basically is in a new state. After that new state, what going to happen is when you click some of an application, for example you click on a WhatsApp, so what happen when you click on WhatsApp? Your WhatsApp start open. Okay, so when you when you click on WhatsApp, your WhatsApp means this process is basically now in a ready position. Your process is now in a ready position, means now your WhatsApp is basically now WhatsApp knows that now I have to execute this thing. Now process is in a main memory. When you click on a WhatsApp, now WhatsApp come in a main memory. So P1 is what? WhatsApp. Okay, now your WhatsApp is in a main memory. When you click on a process, means when user want to execute a particular process, that process is come in a main memory. When it come in a main memory, it means it is now in a ready state. It is now in a ready state. After admitted, after admitted means when you click, when you want to execute a particular process, it goes in a ready state. So I hope it is clear to you that what is a ready state. Okay, so this is what a ready state means. All the processes which are basically waiting to run on a CPU are known to be a ready state. Means your process is now in a main memory. So when your process is in a main memory, it means what? It means that process want to execute. When operating system put the process in a main memory, it means what? It means here that process want to run, that process want to execute. So that process basically wait for a CPU. So all the processes which is waiting for the CPU to execute is in a ready state. So what does ready is? All the processes which are waiting, to execute or to run, to execute on CPU is basically known to be in a ready state. Okay, so that process is in a ready state. So I hope you understand about a ready state as well. After that, after ready state, now your process is in a main memory. So what operating system do? Operating system send that process to the CPU to execute. That operating system send that particular process, because you click on a WhatsApp, now it come in a main memory. So now WhatsApp is start running, WhatsApp start executing. So when your WhatsApp start running, it comes in a running state. Now your WhatsApp is start executing. Now you can able to see, okay, so these are my friends. Now if you want to send some message to your friend, you can do that. Means when your process is executing, when your process is running, so that particular state your process is basically right now is a running state. And who basically do this thing is called a scheduler dispatcher. Scheduler dispatcher. What basically this thing means, we will see this thing or meaning of these things, but for now what you understand is, in a main memory we have okay, so we understand this thing. Okay, what does the meaning of a scheduler and a dispatcher, because it's very important to understand these things. Okay, so what we are going to do is, CPU, we have CPU and we have a main memory, CPU and we have a main memory, or you can say RAM. Operating system, we have, let's say, let's say we have two processes, P1 and P2 and P3. Okay, so we have two processes, P1, P2 and P3. So now your process is basically, when your process is in a RAM, it means what, in which state this process is basically is in a ready state. Okay, so now P1, P2, P3, so we have so many processes in our operating system. So which one operating system is basically start to execute, because all these three programs are very important. So all these things need to be execute, definitely they will execute. Okay, so P1 will be execute, P2 will be execute and P3 will be execute, but in which order, means, okay, so operating system, what it do, it first of all send P2, it then send P3 and it then send P1. Why operating system do that sequence? Why it not send first of all P1, P2, P3 in a sequence or in a decreasing order like P3, P2, P1? Why it not do like this? So there is a thing which is called a scheduler, This is what a scheduler means. Your operating system schedule the processes. Means now P1, P2, P3 get a CPU in which order. So these things will be done by the CPU scheduler. Or in a short you can say scheduler. These things were done by the scheduler. So when your process in a ready state, so which process need to be go in a running state is decided by the scheduler. Okay, so what happen is, operating system decide that P2 is the process that need to be execute first. Okay, so we select P2, means PCB of P2 is now ready to get a CPU. So now a scheduler basically decide, okay, P2 need to be execute, but how the P2 basically get a CPU? So the system which basically get a CPU for P2 is what? A dispatcher. So what dispatcher do? Dispatcher take the P2 process, because scheduler decide the sequence. Now dispatcher select a particular process which scheduler decide, and dispatcher take that process and that process will go to the CPU. So who take P2 and get the P2 to the CPU is the dispatcher. Because scheduler is what's the working of a scheduler? To decide which process need to be execute first. Okay, so P2 need to be execute first. So what dispatcher do? Dispatcher take the PCB of P2, and the PCB of P2 is now getting the CPU basically. So who get the CPU? Dispatcher. Okay, dispatcher is the one who basically collect the PCB of P2 and put that PCB of P2 in the CPU. Now so CPU will be execute the P2 process. So I hope you understand the meaning of a scheduler and the meaning of a dispatcher. It's a very important thing, you need to be understand this thing. Okay, so we understand about scheduler and dispatcher. Now our process is basically in a running state. Our processor is in a running state. After some time your process P2 is running. Let's suppose that your process P2 is running. So P2 is running. After some time P2 need to perform some IO event. What does the meaning of an IO? Input output operations. So what basically the input output operation means? whatever basically is connected to your device is everything is basically an input output operation. Your monitor, mouse, printer, anything basically connected to anything where you can get something or where you can put something is basically an input output device, input output events. Okay, so what P2 need to do is P2 simply wait for some IO operations. So when P2 wait for some IO operations, so CPU become idle. Now what happen is CPU become idle because P2 want to perform some input output operation. So when P2 is not executing, because CPU is now become idle, it means for P2 is not executing, P2 is performing their input output operation. So when input output operation is going on, so that process now go to the another state which is called a wait and block. Wait and block. Why the process move towards this state? Because that process was performing input output operation, waiting for input output event to over. Okay, so now P2 process performing input output event, so that process is now is in a wait, or you can say a block state. So I hope this state is also clear to you that what is this, why the process comes in this state. Okay, after some time your input output operation is done, means P2 want to perform some input output operation. Now after some time input output process is done, means whatever the P2 need, P2 get that thing. So after that the the process which is in a wait state now go to a ready state. This is a very important thing. The process never go in a running state again. Why it's not going in a running state? Because in a memory you can see there we have so many processes. We are not having a one process, we have so many processes. So when P2 perform input output operation, other process what operating system do? Operating system provides CPU to the other processes. So when P2 perform IO operation, P1 is basically start running or start executing. So the process after completion of an input output operation cannot directly jump to a running state, because already one process is running and CPU can only execute one process at a time. So they cannot run the process after the completion of an input output event. So where the process go? The process go in a ready state again, means that process go in a main memory again, means the PCB is now updated and waiting to get a CPU. Okay, so when the process go in a ready state, when the IO event is completed, when your IO event is completed. So I hope it is clear to you that when the process go in a ready state. Okay, easy to understand these things. After that, when your process is in a ready state, after scheduling your process, the dispatcher put your process to the CPU and now your process start running. After some time, what happen is P2 is successfully executed full, means now P2 is fully execute. Now if P2 is fully execute, your process is fully execute, now your WhatsApp work is done. So what do? You simply cross your WhatsApp application, you basically terminate your WhatsApp application. So after that your process is basically terminated, means your process is now exit. Your process is now exit. So I hope you understand these things. Okay, there is a one more thing. If this thing happen, this diagram is called non-preemptive process. This diagram is for the non-preemptive things. This diagram is for non-preemptive process state. You can write it like here, non-preemptive process state. Now if you watch my videos and you understand about the preemptive or non-preemptive, or in a short, what is non-preemptive means? Non-preemptive means the process is basically execute by itself when operating system has not operating system basically not cancel their running time, not basically snatch CPU from the process, not snatch CPU from the process. Means when a process get a CPU, it will execute, it wait when IO operation need to perform. After that the process cannot leave the CPU. So if this thing happen, then this is called, then this is what basically this called a non-preemptive process state. Non-preemptive process state. So what happen if CPU basically operating system basically snatch CPU from a running process? Means okay, so what I want to say is that what happen is basically when this is your CPU and you have a main memory. In main memory you have operating system P1, P2 and P3. So what happen is basically P1 is running very perfectly. What happen is after some time P2 says I am very important for the user, my priority is greater than P1 priority. My priority means the P2 process priority is greater than the P1 process priority. So what operating system do? Operating system snatch CPU from a P1 process. Now P1 process is basically leave the CPU, and now CPU is provided to P2 process. Now P2 process is basically acquire CPU. Why it acquires CPU? Because P2 process is important for the user. P2 process is highly prioritized as compared to P1 process. Okay, so when this thing happen, now this state diagram is called a preemptive state diagram. So this is called preemptive, preemptive state diagram, or you can say preemptive state things. Okay, so when this thing happen, now what basically going on is when operating system snatch CPU from a P1 process, means P1 is running easily, P1 is in a running state. Now what happened, P1 is leave CPU, P1 need to be stopped, so then it goes to a ready state. Now P1 goes to a ready state. Why it goes to a ready state? Because it's a preemptive, because some preemptive process is come, so operating system need to provide CPU to that process. So I hope you understand this thing, that now this is basically what a preemptive state diagram is. Okay, so when your process is come from a running to ready, it's a preemptive process. Because some highly prioritized process need a CPU to perform there, to basically to execute. Okay, and everything is same. So this is what a process state diagram is look like. Okay, so there is no need to write the definition like new is unready, so you can write it by yourself, that what is a running, when a process is in a running state, when process is running in a CPU, is basically that state is called running state. So if you want me, I'd basically write it like that, that what is a running state? Running state means when a process is in, when process is running in CPU, so it has to be known as a running state. Or what means of wait and blocked, when process which are waiting for an input output operation, process waiting for IO operation, And what is the meaning of terminated? Terminated means when process is execute successfully, means fully execute. So that process is basically that state is basically a terminated state. So what one thing you notice in this diagram that, okay, so I paste this diagram once again. Okay, so now, okay, so now this is preemptive case. Now what going to happen is, what you notice is that when whatever the process is in your app, means whatever the application is in your desktop or in your mobile, that is placed in a new state, and when your process is execute fully, it is in a terminate state. Means when it is your process is a new, then it means what? It means your process is not in a main memory. And when your process is execute successfully, means terminated. What does that mean? That means your process leave the main memory. So what does that, what I want to say is that your process, okay, so your process is in a memory till when your process lies between these states. This is a very important thing, because so many times the question asks you that your process is in a new state, so does it in a main memory as well or not? So you have to say no, because your process is in a main memory. Your process, let's say P1, P2, your process is in a main memory when your process is in a ready state, and performing this task, your process will always in a main memory, because of what operating system do? Operating system transfer PCB to the CPU. Operating system never transport your program to the CPU. It basically transfer the PCB of your program. Simple thing. And all these things done in this part, in this two part. So remember this thing, your process will in a main memory till the fully execution of a part, and when your process is execute, so when it exit, means when your process is in a terminate, then only it leave the main memory. Okay, so this is a very important thing, you need to be understand this thing. Okay, after that we have to understand something which is called a transition, or you can say a voluntary process. Means you see that everything is done by the operating system. Means operating system is the one who take the process and provide the process to a ready state. Operating system is the one who who take process from a ready state, operating system schedule this process, and operating system put that process in a running state. When the process want to perform some IO operation, so operating system is the one who put that process in a waiting state. So everything is control of an operating system, isn't it? Everything is control of an operating system. But no, there are two things that was controlled by process itself. This is a very important thing. You can write very important, or you can write like note that there are two things that is in a control of a process itself. What are these two things? When process is running to terminate, when process is running to terminate, what does that mean? That means the process is running, let's say P1 is running in a CPU, and after some time when P1 is fully execute, now user basically cross that application, user basically leave that application, cut that application, because P1 the process is fully execute. Now user doesn't want to execute this process anymore. So when this thing happen, now the process basically move towards the terminate by itself. Operating system never put your process from a running state to a termination state. So this is what the one thing that is in a hand of a process. This is in a hand of a process. Process is basically move from a running state to a terminate state. And what are other thing that is in a control of a process? That when your process is in a running state and move towards the waiting state, or you can say block state, means now the process is easily running in a CPU, and process thing, okay, I need to perform some IO operation. I need to perform an IO operation. So process by itself decide to perform an IO operation. Operating system doesn't decide this thing. Process decide that he want to perform an IO operation. So then now process move towards the wait block by itself. Operating system doesn't do anything in this case. Okay, so these are the two things. To state that in a control of a process. Now everything from moving to undo, new to ready to running, everything basically in a control of an operating system. Okay, so I hope it is understandable that what is these things. Okay, what's in a control of a process. I hope it is clear to you. After that, now you need to understand about something which is called CPU versus IO bond. CPU versus IO bond. Now what does this mean? There are two kind of bonds in a process. First one is called CPU bond, and the second one is called IO bond, and both are basically related to a process. Now what does this thing is? When your process spend more time in a CPU operations, means when a process needs CPU to execute maximum time, your process needs CPU. Process need CPU for a maximum time, means every time the process need a CPU, then that process is called a CPU bond process. That process is called CPU bond process. And on the other hand, when your process perform IO operation very frequently on a maximum time, then that process is called IO bond process. So I hope you understand the difference between these two processes. Okay, so when you let's say when your process need to perform some IO operation, so user want to put some input, so then that process is basically IO bond process, because you are depending on a user to provide an input, or anywhere if you provide for an output, then that process is called a IO bond process. And a process spend more time in CPU for execution, then that process is called CPU bond process. Okay, so if the process is intensive in terms of CPU operations, then it's a CPU bond process. Process is intensive in terms of CPU operations is called IO bond, and when your process is intensive in terms of IO operation, then that process is called IO bond process. That process is called IO bond process. So I hope it is clear to you that what is the IO bond process and what is basically a CPU bond process. So in this video you understand about so many things like new to ready to running, and these so many things. Now we are moving forward into a next thing which is called a process scheduling. What basically now we have to understand is that how the process is basically scheduled. So there are so many things when we understand about because in the upcoming videos we understand CPU scheduling in more detail, but for now what you have to understand that how the process is basically scheduled. So you know that only one process is to be selected among the multiple process to be execute. So you have let's say you have multiple process P1, P2, P3, and you have an operating system. So when you have multiple process in a main memory, but you know that only one process can execute at a time. Among the multiple process. So these thing is basically done by a different scheduling techniques, like first in first out, means how this process is basically selected. FIFO, LIFO, round robin, shortest job. So these are a different thing. We will discuss these things in an upcoming videos. For now, you have to think like that only one process is selected among the so many processes, and when one process is execute fully or it wait for an IO operations, so other process can acquire the CPU. This thing you need to understand right now. Okay, so now there is a thing which is called a scheduling queue. Scheduling queue. Now what does this mean? Scheduling queue. Scheduling queue is of two types. First one is a job queue. What does this mean? Job queue means when all the processes are in a new state, then we can call it a job queue. All the processes, when all the process in a new state, then what we call that all the state basically lies in a queue. That queue is called a job queue. That queue is called a job queue. Okay, so you can write it like the process which is in a new state, process which is in a new state. Now other queue is called a ready queue. Ready queue. Now what basically is there in a ready queue? All the processes which are in a ready state is in a ready queue. Means all the process in this main memory like P1, P2, P3 is basically in a ready queue, because it now become ready to execute. Okay, so these process means all the processes which are in a ready state. Ready state is called a ready queue. And the last one is called a device queue. Device queue. Now what does this mean? Device queue means all the processes which are waiting for the device are kept in its device queue. All the processes which are waiting for a device, are kept in a device queue. Means user want to means the process want to perform some IO operation, so it's waiting for some device. It waiting for depend on an external device, like from a mouse it get an input, from a pen pad it get an input, from anywhere it get an input. So when it depend on that, let's say depend on a mouse, so that process is basically comes in a mouse queue, so at that device queue. Okay, so these are three things you need to remember, because sometimes the numericals and our gate exam is basically come on these topics as well, that what process is basically in a job queue, in a ready queue, or in a device queue. So if you know these things, then you can easily solve that kind of questions. Okay, so now we are moving towards the very important thing. Which is called types of scheduler. Now this is a very important thing. Okay, types of scheduler. So if you understand about this whole structure, whole diagram, how these ready state this thing work, how these diagram work, then you can easily understand about the types of scheduler. So if you want to know about types of scheduler, then simply open the operating system PDF and watch this thing, or click on a next to watch the types of scheduler video. So this is what all about in this video. Thank you for watching this video. Like the video and subscribe my channel.